Here in the sixth section, we will be looking at example A. Example A has been worked for us, but it starts off by saying, now you can prove a theorem that can be used to show that a given quadrilateral is a parallelogram. The theorem states, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. We're given quadrilateral poly, P-O-L-Y, with angle P congruent to angle L and angle O congruent to angle Y. And we are to prove that quadrilateral poly is a parallelogram. All right, well, let's take a look. We started off with saying quadrilateral poly with angle P congruent to angle L and angle O congruent to angle Y. That was given to me. Well, in order for us to say that two things are congruent, we also know that their angle measures are equal. So we say the measure of angle P equals the measure of angle L, and the measure of angle O equals the measure of angle Y. And I'm going to go ahead and mark this while we work through this. We're saying that this angle is congruent to this angle, and we're given this angle is congruent to this angle. Okay? Well, we know that the measure of all four angles inside of this quadrilateral sum up to 360 degrees because the sum of the measures of interior angles of a quadrilateral is 360. So the measure of angle P plus the measure of angle O plus the measure of angle L plus the measure of angle Y equals 360. Well, but I know that P and L are the same measure, and O and Y are the same measure. So I said the measure of angle P plus the measure of angle O plus the measure of angle P because I substituted plus the measure of angle O because I substituted equals 360. Well, then I simplified. I have two angles of P and two angles of O. So I said, well, I wrote on my paper. 2 times the measure of angle P plus 2 times the measure of angle O equals 360. Well, I can use the division property of equality. I can divide the entire thing by 2. So the measure of angle P plus the measure of angle O equals 180. This time I went back and I substituted the other way. I said the measure of angle P plus the measure of angle Y plus the measure of angle P plus the measure of angle Y equals 360. Okay? Well, then I simplified. 2 of the measure of angle P's plus 2 of the measure of angle Y's equals 360. That gives me, whenever I use the division property, the measure of angle P plus the measure of angle Y equals 180 degrees. Well, I know that PY is parallel to OL and PO is parallel to YL. Okay, so let me mark that. And we're going to talk about how we know that. PY parallel to OL and PO parallel to YL. And I know that because consecutive angles are supplementary. If two lines are intersected by a transversal and a pair of consecutive interior angles are supplementary, then the lines are parallel. So because I can prove that these two angles add up to 180 and these two angles add up to 180, I can say that the lines that intersect there are indeed parallel. Well, since I have opposite sides parallel to one another, we can call this figure a parallelogram. because that's part of the definition. A quadrilateral that has opposite sides parallel is considered to be a parallelogram by definition. All right. Here you're going to have try these A. And it says write a proof using the theorem in this example as the last reason. And we're given that RT is going to be congruent to RK. So I'll make some markings here. RT is going to be congruent to RK. Angle RKT, this angle, is going to be congruent to angle U. So these two angles are congruent. And it also states that angle 1, this angle, is going to be congruent to angle 2. And it wants you to prove that TRUC is a parallelogram. On the next particular slide, you're going to see a proof that's kind of been done for you, and you're going to have a drag and drop. So I want you to take your about 4 minutes to work through this before you move on to your drag and drop on the next slide. Go ahead and work through example A, try these A.